Hi, my name is Casey Joyce, and I did problem 17.p.96. In this problem, we have two metal spheres. One small sphere is on the left, marked as sphere 1. It has a small radius denoted as a lowercase r, and it has an initial charge of lowercase q. The large sphere has a large radius with uppercase r and an initial charge of uppercase q. The two metal spheres are connected by a long metal wire. Because the problem asks you, given that it has a charge of original charge of q, what is the final charge in both the spheres? Because the charges are metal, you know that they're insulators. In insulators, you have an E net of 0, and you also have a change in potential of 0, so V is constant. Because we know this, that means you can set the surface of V1 equal to the surface of V2. So the equation for V of a metal sphere is 1 over 4 pi E naught times Q over R of the coordinating charge and radiuses. When you set those equal to each other, you can cancel out the 1 over 4 pi E naught. And so then you get the equation, the charge of the big sphere equals the charge of the little sphere times big R over little r. In this problem, the charge is conserved. This is because the potential at the surface is due solely to the charge on the nearest sphere. So you know the initial charge on the first sphere is equal to the final charges of both spheres combined. This is because the total charge is conserved. So knowing this, you can then go on to the equations that we derived earlier and set it equal to the original charge of the small sphere. So once you use algebra to figure it out, then the final charge of the small sphere is equal to the original charge times the radius over the radius of the small and big sphere combined. Coincidentally, the final charge of the large sphere is the same equation, but it's the final charge of the large sphere is equal to little q original times big R over little r plus big R. Other assumptions we are able to make in this problem is that, like I said, the E net is equal to 0 and V is constant. This is due to the fact that they're both insulators. Also, the spheres are so far apart that they do not polarize. The charge on each sphere is uniform. And as I said before, the potential at the surface is due solely to the charge on the nearest sphere. That is all. Thank you.